So we were looking at the odd and even properties of sine and cosine. Now let's look more closely at the amplitude. You'll notice instead of simply y equals the sine of x, I have y equals a times the sine of x, y equals a times the cosine of x. That changes our key points. X stays the same, but we have a times y. The a is outside of the function, multiplying our y values. When we look at an equation, the amplitude is always the absolute value of a. So it doesn't matter if a is positive or negative, we want the absolute value of a. So let's start with a review. Why don't you write down the key points for our sine function and graph it here. Now, even if you haven't got those key points memorized, we have some steps to follow when we're graphing our functions. We know that sine is between +1 and -1. We know that there are 4 intervals. And we're going up by 90 degrees or pi by 2 radians. Same thing in the other direction. You've memorized the y-intercept at the very least for sine, at least I hope you have. So you can put that on the graph. And then what? Well, we know that sine has x-intercepts at every second interval. So we had one at the origin, every second interval. Same thing in the other direction. So we put on our y-intercept, we next put on our x-intercepts. And then I hope you remember that sine goes up from the origin. So we have this piece of the wave. And as long as you have one piece of the wave, then we know, oops, I went up to 2, not 1. There we go, 1. There we go. As long as we have one piece of the wave, we can figure the rest of it out. It has to go below the x-axis and then back to 0. Same thing in the other direction, down to -1, 0, +1, 0. Always above the x-axis and below the x-axis. Get those key points written down. On the same grid, I want to graph y equals 3 times the sine of x. Remember, that means x isn't changing. We're multiplying our y values by 3. What is the amplitude? Well, the amplitude is the absolute value of a, or +3. You've listed your key points up here. You know you need to multiply each y value by 3. Write down the key points for this graph and then draw it here. You should have a graph that looks like this. We've stretched it out. And if you remember way back to week 3 transformations, when we multiply any function graph by a number greater than 1, the absolute value of a number greater than 1, we have a vertical stretch. We see that this has not changed the y-intercept. It's still at 0, 0. It has not changed the domain. It's still the set of all real numbers. But the range has changed. We now have a range from -3 to +3. Let's look at a transformation on our cosine function graph. I want you first of all to fill in the key points for y equals the cosine of x, and then fill in the key points for y equals 1/2 times the cosine of x. So you found these key points, you've multiplied the y value by 1/2, and again, when we're graphing, we're going to put in our highest point and our lowest point. We see that it's 1/2 and -1/2. And our y-intercept has changed again. Instead of at 0, 1, it's at 0, 1/2. Remember that we have x-intercepts on every second interval. That's still true here. And if you check, you can see at pi by 2, it's equal to 0. At 3 pi by 2, it's equal to 0. We have a piece of our wave here, and we know that that pattern continues. Now below the x-axis, 0, and above the x-axis. Below the x-axis, 0, and above the x-axis. We still have our wave, but this time it's been compressed. So notice that when a is not equal to 1, the y-intercept changes because we're multiplying our y value by a. The domain is still the same, but the range has changed. From -1/2 to +1/2.